are quantum physics, a realm where the rules of classical physics no longer apply. It's like walking through a dream where particles and waves dance together in ways both beautiful and bewildering. Let's start with the basics. Quantum mechanics is a branch of physics that studies matter and energy at an atomic and subatomic level. Unlike classical physics, which deals with macroscopic objects, quantum mechanics delves into the tiny world where particles exhibit wave-like properties. Key concepts include particles versus waves. Particles are atoms and subatomic particles like electrons, protons, and neutrons. Waves, on the other hand, describe quantum objects exhibiting diffraction and interference patterns. Wave-particle duality is another fundamental concept. Quantum objects can behave as both waves and particles depending on how they are observed. The double-slit experiment demonstrates this perfectly. Electrons passing through two slits create an interference pattern indicating wave behavior, but change to particle behavior when observed individually. And then there's the uncertainty principle. It's impossible to precisely know certain properties of a quantum object simultaneously, e.g., position and momentum. This principle highlights the inherent uncertainty in measuring quantum systems, a reminder that our understanding is always incomplete. Now, let's talk about superposition. A quantum object can exist in multiple states simultaneously. Imagine flipping a coin. It's either heads or tails in classical physics, but both heads and tails until observed in quantum mechanics. Mathematically represented using wave functions psi, which describe the probability of finding an object in different states. It's like living multiple lives at once, each possibility existing simultaneously until observed. And then there's entanglement, when two or more quantum objects become correlated so that the state of one depends on the state of the other. Consider two entangled particles. Measuring the spin of one instantly affects the spin of the other, regardless of distance. Entanglement challenges classical notions of space and time by suggesting instantaneous communication between particles, a phenomenon that defies our everyday understanding. Quantum states are described by wave functions, which predict how systems evolve over time using Schrödinger's equation, a fundamental equation used to predict how quantum systems evolve over time. Observations introduce uncertainty into systems. When observed, quantum objects collapse from superposition into one definite state. A reminder that measurement itself introduces uncertainty into our understanding. Famous experiments like the double-slit experiment show wave-like behavior but change when observed individually, demonstrating wave-particle duality. And then there's Stern-Gerlach experiment. Silver atoms passing through a magnetic field, splitting them into two beams, based on their spin orientation showing intrinsic angular momentum. Debate over superposition principle exists. Some argue it's merely interpretation rather than objective property. But reconciling these viewpoints involves understanding that superposition indeed fundamental aspect quantum mechanics. But interpretation varies depending philosophical perspectives. Sources like Introduction Quantum Mechanics by David J. Griffiths provide comprehensive introduction focusing mathematical derivations, experimental evidence supporting key principles like superposition entanglement. Quantum Physics Beginners by Alistair Ray offers accessible introduction, aimed beginners explaining complex concepts, simple terms maintaining scientific accuracy. And then there's Feynman Lectures, Physics Volume 3 by Richard Feynman. Renowned physicist lectures provide engaging, intuitive approach explaining quantum mechanics through analogies thought experiments, making easier readers grasp abstract concepts intuitively. Unraveling mysteries, quantum physics requires patience, persistence, but made accessible clear explanations, practical examples, renowned sources, combined real-world experiments demonstrating principles action.